All right, so again, Pythagorean theorem, it has to do with what kind of triangles? Right triangles, all right? So the first sentence here that we're going to fill in is the Pythagorean theorem relates the like drawing a blank here, relates the, I don't know which words I'm supposed to be using here, relates the sides of the, no, relates the legs of the triangle. Sorry, I had to think what I was trying to say here. The legs of the triangle. No. Hold on. Y'all, I haven't looked at this. I know what it is. I just forgot what words I'm supposed to fill in here. So you give me 2 seconds. Let me pull my stuff out. That's what happens when I didn't look at anything before I started working now. The lengths of the hypotenuse of the legs. There we go. That's what I'm missing. Scratch that out. Erase. I know. I got to get back into school mode, right? All right. Relates the lengths is what I'm trying to say of the hypotenuse. You guys remember which side is the hypotenuse? And the legs of a right triangle. Okay, it relates the length of the hypotenuse and the legs of a right triangle. So remember this. I'm going to call this A, this B, and this C. Which one of those is my hypotenuse? C, the one directly across from the right angle. So it relates the lengths of the hypotenuse. And then these are both called legs. Yep, so this is a leg, this is a leg, and this is the hypotenuse. Okay. So what this Pythagorean theorem does is it relates the legs, the lengths of the legs and the hypotenuse together. It is used to find the missing lengths, again, of a side, no, of a, oh my gosh. Try that one more time. Y'all, I'm sorry. I got to get off spring break mode. Find the missing sides of a right triangle. My bad. I'll get it together, I promise. Okay, it relates the lengths of the hypotenuse and the legs of a right triangle. It is used to find the missing sides of any right triangle. Sides A and B are called the, what did we call them again? Legs. And C is called the hypotenuse again. And do we remember what the Pythagorean theorem says? What is the formula? Yep. So for any right triangle, a squared plus b squared equals c squared. Okay, which we know. We've done this before multiple times. Everybody ready? Okay. The next one is a Pythagorean triple, is what we're going to call it, okay? A Pythagorean triple. You don't have to remember how to spell any of this. Pythagorean triple. How many sides are in a triangle? 3. So what is triple relates to 3, right? A Pythagorean triple is a set of 3, hence the word triple, non-zero numbers such that a squared plus b squared equals c squared. Just stretching. Okay, so a Pythagorean triple is a set of 3 non-zero numbers such that a squared plus b squared equals c squared. And then I just have a list of some common Pythagorean triples there for you. You do not have to memorize them, but some people get familiar with them, and then it helps them when they're solving for the missing side lengths. Okay, the ones that we're going to focus on right now are the top ones. So we have 3, 4, 5, 5, 12, 13, 8, 5, 7, I'm sorry, 8, 15, 17, and 7, 24, 25. Those are our base Pythagorean triples. So watch this. You don't have to write this down. In 3, 4, 5, which one of those would be my hypotenuse? 5, the biggest one, right? So then it would, let's just check. 3 squared plus 4 squared equals 5 squared. Let's see if this is true. What's 3 squared? 9. What's 4 squared? 5 squared is. Does 9 plus 16 equal 25? It does, right? And then you could check it again for the next one. 5, 12, and 13. Which one of those would be my hypotenuse? 13. So let's see if this works. 5 squared, 12 squared, 13 squared. So that's what? 25. What's 12 squared? 144. What's 13 squared? 169. And then if we add 25 plus 144, that equals 169. Okay, not that you have to do that, but I'm just proving to you why these Pythagorean triples work. So if you notice below 3, 4, 5, what is the next 7 numbers? Right below 3, 4, 5. 6, 8, 10, which means I just took 3, 4, and 5 and did what to them? Multiply them by 2. I doubled them, right? And then it goes to 9, 12, and 15. So that would take them and multiply them by 3. And then it goes to 3x, basically 3x times 4x times 5x. That's the base of it. And so what it is, that's just a list. Again, you do not have to memorize them, but if you're familiar with them, it might start helping you solve some of these problems a little bit faster. Is everybody good? All right. So we are going to find the value of x, and it says to round our answer to the nearest tenth. How many numbers is that behind my decimal? 1, right? The tenth place is the first number behind your decimal. So let's look at our picture. I have sides listed as 8, 13, and x. So what we need to do first is decide which one of those is my hypotenuse. Which one is my hypotenuse? 8, 13, or x based off of its placement? X. Okay, so let's set this up. Is everybody ready? So we're going to go 8 squared plus 13 squared equals x squared. Remember, a squared plus b squared equals c squared. C is always the hypotenuse, which is across from the right angle. So you have calculators in your hand. Do 8 squared. Do 13 squared, and let's add those together. Okay, 8 squared is 64. 13 squared is 169. Does everybody see your square button on your calculator that you can just put 8 and then hit the x squared button? Does everybody see that on the calculator? And then if we add 64 and 169 together, what did you say that was? 233? 233, not 330. And then if I have 233 is equal to x squared, how do I figure out what x is? I take the square root, okay? On the calculator, here's what we need to do. I'm going to take the square root of both sides. We're going to round it to 1 decimal place. So what I want you to do in your calculator is hit your second key. Hit your second key. Hit your x squared key. That should put the square root symbol in your screen. And then you enter the number 233 and you hit equals, and we're going to round it to 1 decimal place. So that will be 15.3. Okay. And that's all we have to do. Hit second. X squared. And then your number 233. And then equals. Okay. Everybody good? Everybody get 15.3 in the calculator? All right. I'm going to let you work on 2, but let me ask you a question first. Which one of those is my hypotenuse, 7x or 9? 9. Okay, so that's C. The other 2, it does not matter which one I call A and which one I call B. It really doesn't matter how you set it up. I could call 7A or I could call XA. It really doesn't matter. We're going to square each one of them. So I'm going to say 7 squared plus x squared equals 9 squared. This equation's a little different. We have to solve it a little differently. Go through and square all of your numbers first. You put the number and then hit the x squared button, or either you just do that number times itself. What is 7 squared? I can't square a variable, so I'm going to leave that as x squared. What is 9 squared? 81. Now, this one is different because my x squared is in a different position. I need to, before I take the square root, I need to get x squared by itself. How would I do that? Subtract 49 over. Yeah. Okay, so that goes away. That leaves me with x squared equals, we're going to do 81 minus 49 in the calculator. What does that give me? 32. And then again, to solve for x, now that it is x squared equal a number, I need to take the square root of 32. We're going to round it to 1 decimal place. So in my calculator, again, I'm going to hit second, x squared, enter the number 32. We're rounding it to 1 decimal place. What do you guys get? 5.7? So far, so good. Now, 3 is going to be a little trickier. Anybody have any questions on 1 and 2 before I move to 3?
And you know the baseball team beat the number 1 team in the nation last week?
You talking about who?
Baseball,
I did not know that.
the nation last week.
Good for them.
That's great.
All right, first question. Do we see some congruency marks in the spectrum? Yes. So I have 26 at the top, I have 40 at the bottom, and I have 20 on the right side. What is also on the left side? 20 because of those congruency marks. So I'm going to put that here. So far, so good? Now, if you notice, my x is right here. And if I look at this piece of my picture only, does that form a right triangle? Yes? Okay. So here's the question. I'm going to come over here and draw this picture to the side for a second because I like to look at things separately. I know that this is 20, and I know that this is x. Do I know what that bottom part is right there? No. Well, I didn't understand what you just said, but we can figure it out. We can figure it out, right? Okay, cut off either side. What shape do you have there in the middle?
That's a square to you.
Well, it might be, it looks like a square, but it might just be a rectangle though, right? Because I'm not sure that all 4 sides are congruent. And let me tell you why. Let's focus on this. This shape right here in the middle. It may be a square. I'm not 100% sure yet because I don't know what x is. But either way, it's a rectangle. So if that top part is 26, what is that bottom yellow highlighted part? 26, okay? But this tells me the whole thing is how much? 40. So if you look at this, how many pieces, I'm going to highlight them in green, do I have that are still needing to add up to be 40? 2. So do this in your calculator. Do 40 minus 26. Take the whole thing and subtract out that bottom part of that square or rectangle, whichever one it may be. You get 14, right? But then we need to cut that into how many equal parts? 2. So each one of those green pieces would be 7. Does everybody understand how we found that? The top part is 26. If we look at that middle section, we know it's at least a rectangle. And so we know from our rectangles, opposite sides are congruent. So I take the whole piece 40. I subtract out the 26. The leftover parts, I cut it in half. So this piece over here is now 7. Okay, set that up. Solve for x. Decide which one of those is your hypotenuse. Okay, I'm looking at this little triangle I drew separately. You might want to draw that triangle separately off to the side. You don't have to. It's just a recommendation. That is a 20. Figure out which one of those is your hypotenuse. Set up your Pythagorean theorem and solve for x. We are still rounding it to the 10th place. squared plus that squared equals. There you go. Yep. It looks like a square, but we have to kind of keep just like this. But we do that at the side. Which one is my hypotenuse? X 7 or 20? 20. All right. It doesn't matter how we set the other two up. I'm going to do x squared plus 7 squared equals 20 squared. What is 7 squared? 49. What is 20 squared? Okay. And then what do I do first? Subtract the 49. So that's going to be x squared equals, thank you. And then we're going to take the square root of both sides. 18.7. Okay. Everybody else get 18.7? Any questions there? Okay. So take a minute and read the next question, that little paragraph. Not really a paragraph, it's just a couple of sentences. Read what it says and try to imagine what that looks like. Take a minute and read your question. The next example with all the words. It says Lincoln High School is installing more wheelchair ramps around the school. One of the new ramps needs to have a base that is 12 feet long and reaches a height of 1 foot. If the side of the ramp forms a right triangle, how long should the inclined surface of the ramp be? Okay, is everybody ready to make a picture? Where's the base? Bottom. Okay, and how long does it say that is? 12 feet. And then it says it has a height of 1 foot. So if I'm talking about the height, we go straight up. Okay. And it says it forms what kind of angle there? Right. And so we want to know what the incline should be. Okay. Look at my picture. Look where I put my numbers. Think about the words that they said in that problem. That the base of my ramp, think about ramps, they go up, right, at an incline. The base of it, the bottom of it is 12 feet long. It has a height of 1 foot. When we talk about our height, it's straight up and down. And we want to know how long the incline should be. Now that you have yourself a picture, you can set this up and solve for the missing part. Decide which one is the hypotenuse. Use your Pythagorean theorem. And figure out how long that incline should be. And it says round it to the nearest tenths place. That is, again, 1 decimal place. This would be something that they would give you on the EOC. That would give you a word problem. Expect you to be able to draw a picture to represent that and then to be able to solve the problem. And they're not going to give you very many straightforward questions. You're going to have to think about things. Which one of those is my hypotenuse? X, okay. So we're going to go 1 squared plus 12 squared equals x squared. What is 1 squared? And 12 squared is? 1 plus 144 is 145. And we're going to take the square root of 145, round it to the tenths place, and we get 12.5. 0. Technically, if you left that as 12, that would be okay, but because they said 10th place, I always like to put that decimal, even if it is a 0. Does anybody have any questions? All right, Pythagorean theorem is pretty straightforward, yes, as long as you know which one is the hypotenuse. All right, now we're going to talk about the converse. Remember, the converse is just switching things around. So if a squared plus b squared equals c squared, then it is a right triangle. But more specifically, we can determine whether it is a right triangle, an acute triangle. What does acute mean? All of my angles are less than 90. Or an obtuse triangle, which means one of my angles is higher than 90. Okay, so it's either going to be an acute, which means all of your angles are less than 90. It is going to be obtuse, which means one of your angles is greater than 90. Or it will be a right, which means it is going to be equal to 90. Is everybody ready? We have some things we need to fill in, and we need to remember these. So given a triangle with sides A, B, and C, if c squared is greater than a squared plus b squared, okay, if c squared is greater than a squared plus b squared, then the triangle is obtuse. That means one of the angles is going to be greater than 90. Okay, if c squared is greater than a squared plus b squared, then the triangle is obtuse. Everybody get that one? All right. If c squared is less than a squared plus b squared, then what do you think the triangle is going to be? Acute, yep. Okay, if c squared is less than a squared plus b squared, the triangle is acute. And then the last one says if c squared is equal to a squared plus b squared, what kind of triangle would that be? Right. Okay. You need to know those. And then it says it has a bold statement right there under it. You need to know that too. We always want to keep c squared on the left side to avoid confusion. Left side when we set these things up. Okay, so if c squared is greater than a squared plus b squared, it is going to be an obtuse triangle. If c squared is less than a squared plus b squared, it is going to be acute. And if c squared is equal to a squared plus b squared, it is going to be right. Okay, but what does it say? First, we have to do what? Determine if the side lengths can form a triangle. Do you guys see where it says that right here? Do you guys remember how to do that? Very close. Okay. If your numbers are listed in order, then yes, it will be the first two. But in case we switch the order of them up, we want to add the two smaller numbers. Okay. If the two smaller sides are greater than the third side, then yes, it can be a triangle. If those two smaller numbers do not add up to be something that is bigger than that third side, then we can't make a triangle. Therefore, I can't tell if it's acute, obtuse, or right anyway. Does that make sense? Okay. A lot of the times your numbers are listed in order, so we do look at the first two, but every now and again they're going to change the order of them and try to confuse you. So it's always the two smaller sides. Is everybody ready? All right, let's take a look at the first one. 3, 7, and 9. What are my two smaller sides? 3 and 7. Do those add up to be greater than 9? 3 plus 3? Yeah, they do, right? So this can be a triangle. Everybody agree with that? Okay. So now we want to continue. We want to decide if this is an acute, obtuse, or right triangle. Which one of those numbers is C? 9. Okay, so this is what we want to do. We want to do 9 squared. And then I'm going to put a little blank because I'm going to either fill that in with greater than, less than, or equal to. And then I want to take the other two numbers. Order does not matter. And I'm going to square both of them. So I'm going to take 3 squared plus 7 squared. Is everybody ready? What's 9 squared? 81, okay. And then what I want you to do is 3 squared plus 7 squared.
58.
Derek. Does everybody agree with 58? Okay, so let me ask you this. Is 81 greater than, less than, or equal to 58? Greater than, which means this is what kind of triangle? Obtuse. Okay, so first we have to decide, can it be a triangle? Then we have to then figure out, is it greater than, less than, or equal to? So take number 2. First of all, I need you to decide if it can be a triangle. 20, 21, and 29. It can, okay. So then what I want you to do is set it up and do c squared first. C squared, or c is always the larger number. Put a blank. Then do a squared plus b squared. And then we want to compare. Is c squared greater than, making it obtuse? Is c squared less than, making it acute? Or is c squared equal to, making it right?
They're the same.
So what would that mean?
They're the same.
So acute, obtuse, or right? Right. Which one is C?
29.
And then I'm going to do 20 squared plus 21 squared.
That's how you do it the whole time.
Got 841 on both sides. So they are equal, meaning it is a right triangle. Did everybody get the idea? All right, do those last 2.
Wait, how do you get the number on the end?
Which one? Left side or right side?
58 at the bottom and at 8.
Oh, so I did 3 squared, which is 9, plus 7 squared, which is 49. You can enter it all in the calculator at once if you want to.
What is the what if the two numbers are the same? 17 and 17.
So that means it can't be a triangle, so you just say not a triangle when you move on.
Oh.
Okay, if it can't make a triangle, there's nothing else you can do. You just say not a triangle and you move on. Remember, you first have to determine if they can be a triangle. Okay.
Wait, so you said if they are the same number, it's not a triangle.
So if you add your 2 smaller ones and they are equal to or less than that third number, it is not a triangle. So I'm assuming y'all are telling me number 3 is not a triangle? No, because 4 plus 11 is only 15. That is not greater than 16. So not a triangle. Can't do anything there. What about 4? Can that one be a triangle? Yeah, 17 plus 17 is bigger than 22. Which one of those is C?
Oh.
22.
What you just said is
I thought you were talking about you added the 2 smaller ones. Greater than, less than, or equal to? Less than, which means this is acute. Anybody have any questions? Everybody get the idea?